Hi team. Week 6 will be covering the second part of irrigation. The one concept I wanted to highlight in this video is determining water requirement, or a method to help you predict how much water your golf course might need. Linked in the email for this week are some additional videos on irrigation systems that I encourage everybody to watch. But I'm just going to go through an example here with Laurel Creek and how you can use some simple math to determine how much water is required on the golf course. So for example's sake, we're going to say we have 45 acres of irrigated turf at Laurel Creek. Based on historical data, the peak month for Mount Laurel, New Jersey is June with an ET rate of 6.08 inches a month. That basically just means that over time they've analyzed the area and they determined that the most amount of water is required in the month of June, and that typically means that crops require 6.08 inches of water per month to remain healthy. Another important thing, which is described a little further in one of the attached documents, the watering information sheet, is the KC value, which is the crop coefficient. This is another research determined value, and the 0.85 is specific to cool season turf species, which is what we have at Laurel Creek. So we're going to go through an example now to determine what is the highest weekly turfgrass water requirement for Laurel Creek, assuming that the irrigation system is 80% efficient and there has been no rainfall. So the first step to these calculations is to take the June ET rate of 6.08 and we're going to convert that to a weekly figure. So we can break this inches per month unit as a fraction like this. So you have your inches and your month, and then you just convert knowing that 1 month equals 30 days. So we orient this with month here so that these units will cancel. So your month cancel. Then you go to 7 days in 1 week. Your days cancel. So then you can now multiply across 6.08 times 1 times 7, divide that by 1 times 30 times 1, and you find that our peak weekly irrigation requirement will be 1.42 inches of water per week. Now we use that weekly ETO rate of 1.42, and we're going to use that to calculate our net irrigation requirement for the peak week. So you look here, net irrigation is your ETC, which your ETC is the ET rate for your specific crop. So for us, that's cool season turf. That's why you need this crop coefficient. And so the first thing we're going to calculate is this ETC. But remember, we're assuming that there's no rainfall. So you notice that the net irrigation requirement equals the ETC rate minus however much rainfall you got. Well, we're assuming no rainfall, so we come into this situation where when you have no rainfall, your net irrigation requirement is equal to your ETC value. So we are just going to find the ETC value and it'll equal the net irrigation requirement. So you multiply your ETO weekly by the 0.85, which is the crop coefficient, and we find out that our net irrigation requirement is 1.2 inches of water per week. You now use the net irrigation requirement to correct for the efficiency of your system. So even the most modern irrigation systems aren't going to be 100% efficient. 80 is a good percentage to assume. So we're going to just assume that our irrigation system is 80% efficient. So you see this here, your gross irrigation requirement is equal to the NIR, net irrigation requirement, divided by the efficiency of the system. So from the last slide, we got the inches per week divided by 0.8, which is 80% in decimal form, and we find out that our gross irrigation requirement for cool season grass is 1.51 inches per week. Now, remember, this is for a peak week, so the most irrigation required, and we're also assuming no rainfall. So this is essentially trying to prepare for a worst case scenario. In general, as mentioned in the watering information sheet, the general rule is that turf requires about 1 inch of water per week. So as you'll see, this extra ½ inch on what would normally be expected is a massive amount of water that has to be added during a peak period of irrigation demand. So now we will use the gross irrigation requirement to calculate our highest weekly turfgrass water requirement. So the first thing I want to point out here is this conversion factor for an acre inch. So this is a figure that tells us that 27,154 gallons of water are required to cover 1 acre of land to a depth of 1 inch of water. So useful factor here. So what we'll do is we start with, from the example, we set our 45 acres of irrigated turf. Now we're going to use our conversion factor here, and here's our GIR. All right, so we kind of line it up so that the units are going to cancel. So we look here and we find our acre, and there's an acre down here, so these two will cancel out. Inches, we have an inch in the denominator, an inch in the numerator, so those cancel, and that leaves us with gallons and weeks, which is what we're looking for our water requirement. We want to know how many gallons we'll need per week. We have those here, so now we just multiply all the values in the numerator and divide by all the values in the denominator. Pretty easy because the denominator only has ones in it. So we just go across the numerator where we have 45 acres, 27,154 gallons, and then we multiply the 1.51 inches from our gross irrigation requirement, and that totals to about 1.8 million gallons of water per week in a worst case scenario. All right, so let's factor in some precipitation. So everything we just went through can stay the same. We still have the same ETO values, ETC values the same, and this just is the highest requirement that we just calculated. So remember, the net irrigation requirement is what will change based on rainfall, because your net irrigation requirement is your ETC minus however much rainfall you got. Okay, so if you get a 1/4 inch of rain, your NIR is now 0.96 inches. That makes your gross irrigation requirement 1.2, and your water requirement is about 1.5 million gallons of water per week. So that's about 378,000 gallons less than your highest requirement when you assume no rainfall. Okay, so this is why it's important to track the amount of precipitation you get on the golf course, because you see even just a 1/4 inch of rain impacts the amount of supplemental irrigation you're applying by at a tune of 378,000 gallons of water. You apply an additional 378,000 gallons of water when you don't have to. That's definitely not something you want from a conservation standpoint, and also that's going to increase disease pressure by your own mistake. All right, so when we look at this chart, eventually we get down, you can get enough rain The ETC value, once you exceed your ETC value in rainfall, you're going to have a negative uh, weekly water requirement because you already got what this model predicts you'll need. Okay, so over 1.21 inches of rain in a week, theoretically you wouldn't need to run any irrigation. All right, because you can also see here 1.5 inches of rain dumping nearly 2 million gallons of water on the golf course. So these types of calculations, they're not precise. Well, they're relatively precise. They're not the only way you can monitor how much irrigation. It's not the only way you're going to make decisions, but from a standpoint of taking a couple variables, moving around, you can kind of get an idea of what you're looking at for water requirement. So, like I mentioned earlier, there's various other resources in this week's email that I recommend you take a look at. That's going to wrap up irrigation, and we're on to something new next week. So, let's have a great week.